Either you accept man-made climate change is a terrifying existential threat to civilization, or you're about to say something funny in the comments section because you don't know the half of it. Whatever the condition may be, let us all agree that humanity is spewing much too much carbon into the atmosphere. Are you still not convinced? Here are some figures. Carbon dioxide levels in the ambiance were around 280 parts per million prior to the Industrial Revolution. Respectable climatologists agree that we need to maintain that amount below 350 parts per million if we want to make our world habitable. Anyway, since you asked, we surpassed 420 this year. Nice. Except it isn't. Of all, we know that reducing carbon dioxide emissions will help prevent a catastrophic runaway greenhouse effect, which will disrupt ecosystems, disrupt food supply, and result in a historical global refugee crisis. But what if there was a means to remove the carbon already present in the atmosphere, thereby turning back the clock? Hello guys, how is your day going? Hope you're having a great time. Before we proceed with this video, do not forget to subscribe to our YouTube channel. Kindly click on the notification bell to get updates on our exciting content. Join us today as we look up into the sky and wonder aloud if carbon capture can save the Earth. Carbon capture is a relatively new field that is continually evolving. But for the purposes of this discussion, let's assume that there are two types of carbon capture and two types of carbon disposal. CO2 can be extracted from industrial emissions at the source, such as coal-fired power plants' bellowing chimney, before it is released into the atmosphere. This so-called flue gas technique is already in use at a few select facilities, such as the coal-fired Boundary Dam plant near Estevan, Saskatchewan, Canada. This technique, which uses complex ammonia-based chemistry, successfully absorbs about 1 million metric tons of CO2 per year, or 90% of the emissions from the Saskatchewan plant. The negative is that the equipment required to accomplish this costs $1.3 billion. The other type of carbon capture, known as DAC, direct air capture, is far more intriguing. DAC, in essence, uses massive banks of fans to extract already emitted carbon from the ambient environment. Although this technology appears to be very promising, it is yet to be implemented on a large basis. More on those later, once we address the thorny issue of what to do with the carbon once it's been captured, whether through flue gas extraction or stolen from thin air. Here too, there are two broad approaches. Carbon capture and storage, CCS, is a phrase that refers to the process of capturing and storing carbon dioxide. The recovered CO2 is kept out of harm's way under CCS, usually underground in safe rock formations. CCU, on the other hand, is a term that stands for carbon capture and utilization. CCU allows carbon to be recycled and put to good use, such as a raw material or feedstock. This sounds terrific, but it also raises a lot of questions. Let's have a look at a couple of CCS, carbon capture and storage projects, that are currently underway. Northern Lights is a highly formidable project being carried out by Shell, Total, Equinor, and the Norwegian government in partnership. Emissions from industrial flue gases from companies across Norway and eventually Europe will be recovered and sent by pipes to a seaside terminal at Øygarden on the North Sea coast. The poisonous CO2 waste will then be transported out to sea on specially built ships, where it will be injected into storage reservoirs 2,600 meters into the seabed. Northern Lights is the first project of its kind to be attempted at scale, promising to save 1.5 million tons of CO2 per year at first, with the capacity increasing to 5 million tons per year once the model CCS as a service, in effect, demonstrates its efficacy. We'll find out in 2024 when it's up and operating. If you can't wait that long, Iceland's Orca project, a carbon capture and storage project, will begin operations in September. Orca is a futuristic carbon capture device created by Swiss business Climeworks. Air capture consists of massive banks of fans sucking CO2 into smart filters, which are then heated to separate the pollutant before being pumped into safe basaltic rocks well beneath Iceland's rocky landscape. The issue of where to put all that CO2 is, of course, at the heart of the carbon capture conundrum. Basalt rocks are perfect because CO2 combines with the naturally abundant magnesium and calcium in basalts, changing the problematic elements into solid minerals such as dolomite, calcite, and magnesite. The argument is that if the ultimate result is rock solid, it will also be stable and won't cause any problems in the atmosphere or, by extension, civilization anytime soon. Oil and gas reservoirs such as those proposed by Northern Lights to store CO2 beneath the North Sea are also beneficial. They're obviously porous and have a lot of storage capacity. We know this because it's where a lot of the oil and gas that we've been happily burning for over a century came from. There is plenty of underground areas to go around. According to studies, the US alone has the underground storage capacity to store 10.8 trillion tons of the substance. Anxiety naturally arises when subterranean watercourses are contaminated. Yet, in most situations, the deep saline groundwater systems under threat aren't part of the drinking water system in the first place. Interestingly, scientists have considered injecting CO2 into the ocean for a long time. Carbon dioxide is denser than water at a suitable depth. Therefore, it should remain in place permanently. Nevertheless, there's no way of knowing what that might mean for vulnerable marine ecosystems, and the unpredictability of huge ocean currents makes everything a little dicey. The prospect of CCU, remember, that's carbon capture and utilization, is far more enticing. Many brilliant people and startups are working on methods to turn carbon that is intended to float around in the atmosphere into useful terrestrial products. Take, for example, these stylish H&M sunglasses, which are made of CCU-based carbon-negative thermoplastics, or these interface carpet tiles from the United States. Climeworks has worked out a way to repurpose captured atmospheric carbon as the gas that makes your drinks bubbly once more. Mineral Carbonation International, an Australian company, seeks to use carbon in bricks to store a large amount of carbon for at least a century, as part of the company's ambitious goal of locking 1 billion tons of CO2 into its goods by 2040. The great, terrible irony of carbon capture and utilization is that, at least for the time being, its primary commercial use is the filthy industry of EOR, or enhanced oil recovery. CO2 is pumped underground at drilling sites as part of EOR to assist drive valuable crude oil deposits to the surface, where they may be retrieved more easily. If the sound of that makes you uncomfortable, that's understandable. EOR is responsible for around 3/4 of all subsurface carbon sequestration. It's helpful in the sense that carbon that would otherwise end up in the atmosphere is kept out of harm's way, but it's clearly terrible in the sense that it eventually leads to the burning of even more fossil fuels, and it's clear that we need to go over it. Nonetheless, somewhat encouragingly, a major EOR facility in Petronova, Texas recently closed because the pandemic-related oil price fall rendered EOR unprofitable. In either scenario, whether the carbon used for pumping out oil comes from recovered emissions or virgin mined carbon makes no difference in terms of enhanced oil recovery. Of course, this is less expensive, and the oil companies secretly prefer it. This leads us to the core issue of scaling up carbon capture projects. For the time being, no bright young entrepreneurs have a strong financial incentive to develop and scale their technology. Electric automobiles, as well as solar panels to a lesser extent, are gleaming futuristic technology that people are eager to invest in. Elon Musk can make as much money as he wants by selling fast automobiles. Carbon capture, on the other hand, is a lot more mundane, with the advantages likely to be felt many years or decades down the road. It's difficult to promote and much more difficult to get passionate about. But it ought not to be this way. Carbon is obviously valuable. It's beneficial. All policymakers need to do now is figure out how to make captured carbon more cost-effective than virgin carbon. A massive industry can be established today in order to reach the International Panel on Climate Change's aim of removing 10 gigatons of CO2 net from the atmosphere by the middle of this century. Off the seashore of Norway, the Northern Lights project is a promising start. Climework estimates that around 80 million of its extraction units, which can be deployed almost anywhere on the planet, ideally near renewable energy sources, could significantly reduce atmospheric carbon emissions. That may sound like a lot, but it's about the same as the number of cars produced each year. There is a way where there is a will. In reality, carbon capture and utilization will always be a sideshow. Much of the recycled carbon which is employed in food or alternative fuels will eventually wind up back in the sky. Current solutions on the drawing board, such as using molten electrolysis to alchemize recovered carbon into nanotubes that can replace construction steel, would be fantastic. But they are far too speculative to be relied upon at this time. For the time being, smart subterranean sequestration is the way to go. And with dizzying incentives on offer to whoever discovers out how to do it on a large scale, not least our pal Elon's nice 100 million Carbon X prize money, the nefarious financial motive might well rescue our collective bacon after all. We just cannot afford for carbon capture to remain an underground technology as a civilization. There you have it. Can carbon capture save our planet? What are your thoughts? Is there a better method to reduce atmospheric carbon and prevent climate change from becoming uncontrollable? Let us know in the comments. And don't forget to subscribe for more engrossing tech stuff. If this video was insightful, don't forget to like this video. Don't forget to share, like, and subscribe to our YouTube channel, and click on the bell button to be notified whenever we upload videos like this one.